So we save these, Ellie, we deposit them on something called Panopto. So people can go back and look at them. So good morning and welcome to the University at Buffalo Jacobs School of Medicine Department of OBGYN Grand Rounds. In particular, I'd like to thank our faculty in all departments, community physicians, residents, medical students, staff, and learners of all ages and stages with an interest in women's health and gender medicine for attending and participating. Questions are always welcome. Before we get started, a few housekeeping items. So our presentations are recorded and available online with links that can be found in the announcement emails that you receive. And CME credit is available for attendance. Please feel free to contact Jennifer Perry for more information. We will embed a Zoom link for you to enter your comments and questions, as well as your feedback at the end. Please let us know what topics you might be interested in hearing in the future. And it is now my amazing pleasure to introduce Dr. Ellie Adachi, who is got more initials after his name than almost everybody else, except for a few folks I've met. And he will be giving a presentation today entitled In Vitro Gametogenesis. And a few more words about Dr. Adachi. He is among the most accomplished individuals in our field. And now I'm going to say our field is reproductive endocrinology and infertility. And he started out with an amazing mentorship from the Joneses. So Howard Jones and Georgiana Seeger Jones were really the individuals who most put IVF in the forefront in America. And that was in the early 80s. So he's still involved with the Jones Institute, which is in Norfolk, Virginia. From there, he actually ended up so they were at Hopkins and Dr. Adachi was at Hopkins. And then you actually toured the United States, right? You went to San Diego, where he worked with Dr. Yun, who's also an incredibly famous individual and put on the map many different aspects of reproductive endocrinology and wrote the seminal textbook of the time. And if you would like to ever look at any of the versions, I have all of them except maybe the last one. But it is an incredible textbook. I keep in my office the one that Dr. Adachi co-authored with Dr. Rock, which I love that book enormously. It's and Zev Rosenwex, I believe. So among his many other honors, though, he has really pioneered a career now in the ethics of reproduction and other issues related to the practice of medicine. And so he has really, I think, launched an entirely new career after having been a basic scientist for many years and running his own lab, become, as emeritus former dean of Brown, a voice for reason and insight and enlightenment in our field. And it is on that basis that he's going to be speaking and sharing with us today his talk on in vitro gametogenesis, the coming revolution. Dr. Adachi, I cannot thank you enough for joining us.
Well, thank you, Sarah. Can you hear me all right? Mm-hmm. Okay. So today we will speak more broadly, really about the notion of stem cell medicine. I'm going to try and illustrate this briefly at the outset, but the young members of the audience are looking at the future that we did not have the privilege of experiencing. We will try to comprehend the application of stem cell medicine specifically to reproduction, because of course, that is our field. And by the by, although I speak separately about this, we will discuss the prospect of same-sex genetic parenthood, which is obviously a brand new notion that was not envisioned at the time of Adam and Eve. And to begin, I always feel that it's important to recall that in 2028, we will be celebrating the 50th anniversary of IVF, which, if I'm correct, is the predecessor of IVG in a sense. By that I mean it will be modified by IVG, although the term may well remain. I don't need to tell you that this major accomplishment was written up at the Lancet in 1978 by Professor Steptoe and Edwards, all about the birth of lovely Louise Joy Brown, who is shown here in the arms of her mother, Leslie. Professor Edwards ended up in 2010 receiving the Nobel Prize in Physiology and Medicine. And you'll be well within your rights to inquire, why was Professor Edwards selected and why were his co-investigators, Professor Steptoe and Jean Purdy, excluded? They really were not excluded. Sadly, both of these two passed away by the time the Nobel Prize was announced. And so it was really just Professor Edwards who ended up receiving the honor. To be even more precise, Professor Edwards was unwell at the time and unable to travel to Stockholm to receive the award. It was his wife who, in fact, made the trip and collected the award, if you will, on his behalf. Professor Edwards himself ultimately passed away in 2013. This is the Lancet obituary thereof. In the United States, we were slightly behind, as you know. It took us 3 more years to get there, thanks to the so-called Norfolk team, which in many ways drew, of course, on Howard and Georgiana Jones, who came from Hopkins in 1978. Ultimately, on December 28, 1981, the first American IVF baby was born, and that was, of course, Elizabeth Jordan Carr, who was the first American IVF baby and who was displayed on virtually every outlet in the nation, from the Boston Globe to Life magazine and beyond. But today we will talk about the successor of IVF, or the modifier of IVF, and that's what we refer to as in vitro gametogenesis. The beginning has everything to do with the brain power of these two Japanese investigators, Mitinori Saito from Kyoto University and Katsuhiko Hayashi from Kyushu University. It was probably around 2013 or so, when I was in Japan for another reason, that I booked a flight to Kyoto and met with the two gentlemen who at the time were working together, and spent a whole morning with them, learning firsthand about their early work on in vitro gametogenesis, which I was increasingly being aware of, but was still somewhat in its very early stages. As you can imagine, as this field progressed, it progressed along 2 parallel lines. For the most part, use was made of the rodent as the experimental model, but increasingly, and I'll share that, of course, the human model was incorporated into the work of the Japanese investigators. Now, to understand in vitro gametogenesis, we have to understand stem cells. and most importantly, so-called pluripotent stem cells, which come in two varieties, embryonic or induced, and I'll, of course, elaborate. What is so powerful about stem cells is that they can become any cell type we wish if we know how to do it. They could become, for example, amacrine neurons in the retina when such are missing. They could become dopaminergic neurons that could be theoretically placed in the striatum in individuals who suffer from Parkinson's disease. And they could constitute motor neurons and in principle make a paralyzed man walk. You may be surprised to see that some of these goals were already accomplished. Nature magazine, in March of this year, carried a report wherein exactly what we just said was described. A paralyzed man was given an injection of stem cells into his spine, and lo and behold, that man started walking. More recently, in May of this year, in Nature Aging, a paper saw press which emphasized the role of stem cell therapy for Parkinson's disease. So what we are discussing today is evolving as we speak. And there's every reason to believe that the reproductive implications are just a question of time. And specifically, we will talk today about stem cell-derived gametes. Science magazine understood the significance of this development and dedicated a whole spread to this issue in 2021 in a review article authored by our two Japanese friends. The New England Journal of Medicine, not to be outdone, commissioned a similar paper from Mary Herbert and Azim Surani, both from the UK. The paper was titled Oocytes from Stem Cell. And more recently, in 2023, that would be in April 2023, the National Academy of Medicine put on a 2.5-day workshop, which I had the pleasure of initiating and chairing, which was specifically dedicated only to in vitro derived human gametes as a reproductive technology. Lastly, the Nuffield Council on Bioethics, which, as you know, is the premier bioethical institute in the United Kingdom, placed in vitro derived gametes at the top of its reproductive agenda. Yes, they're going to be dealing with time limits on maintaining embryos in culture. They'll be dealing with womb replacements, preconception screening, whole genome sequencing of embryos, of fetuses, genome editing of gametes and embryos, egg freezing, etc. But at the top of the list, they have in vitro derived gametes. So what is in vitro gametogenesis? For once, we can all agree that it is a disruptive technology. It hasn't been here before, and it's going to shake up everything you and I know about reproduction. Is it achievable in the human? Time will tell. And what timeline are we talking about? To be sure, the human component is still in development, and I will point all of that out, of course, but the likelihood is that the young members of the audience are likely to reap the benefits of this new technology once it is mature and once it is FDA approved. And I'll talk about that a little bit later. But to understand IVG, as I alluded to earlier, you have to understand pluripotent stem cell formation technologies. There are really two ways to get there. One is the so-called somatic cell nuclear transfer technology that was developed in 1958 by John Garden, then at Cambridge University in the UK, who used frogs and essentially used a somatic nucleus, transfected it into an enucleated oocyte, and created effectively a zygote from which he derived embryonic stem cells. This technology is not really in use today, but I mention it for historic completeness. In 2006, the so-called induction technology was introduced by Shinya Yamanaka from Kyoto University as well, in a paper published on the pages of Cell. He started with a somatic cell and transfected it with a select number of transcription factors and ended up with what we now call induced pluripotent stem cells, which is really the coin of the realm and what we use today to proceed to a gametogenic fate or to some other fates. Both gentlemen received the Nobel Prize in Physiology and Medicine in 2012 in recognition of the fact that stem cells really represented breakthrough technology. So now moving into in vitro gametogenesis, we can all agree that we'll start with a somatic cell, say a skin cell. We can now, using one of those technologies, convert the skin cell into either an embryonic or induced pluripotent stem cell, and then guide that stem cell towards a gametogenic fate. Now, how do you do that is easier said than done. There are some prerequisites we need to have. We have to know what cues would have to be applied, by which sequence, what timing, and we will also have to take into account the niche in which these cells are encased. I don't have to tell you that oocytes are surrounded by granulosa cells, and sperm are surrounded by Sertoli cells. And so nothing really happens in the germ cell absent the input of the surrounding somatic cells. So we have to take into account the so-called niche. The beginning of IVG was quite modest and can possibly be traced back to 2003, when a science paper was published, senior authored by Hans Schurler, who then was a postdoc at the University of Pennsylvania, but is now the director of a Max Planck Institute for Molecular Biomedicine in Germany. This was very early work. The photograph on the right lower hand side illustrates the kind of oocyte that served as a subject of the paper. That same year, Toriaki Noche from Japan published a similar paper in the Proceedings of the National Academy of Sciences. And a year later, George Daly, who is now the dean of Harvard Medical School, published a paper in Nature on the very same topic. And finally, at that time, René Rejo-Pera, who was then at UCSF, published a similar article. In the subsequent decade or so, we have witnessed papers come out in the rodent arena, Nature, Science, and Cell, and on the human side as well, in Nature, Cell, Embryo Journal, and Cell and Stem Cell. And so the field was gradually and slowly progressing and was gaining increasing number of investigators who were being recruited into the field. So as we look at where we were in 2015, we can say that the germ cell specification pathway is not concerned between the rodent and the human. So those studies would have to be conducted separately, and that the genetic networks involved are quite distinct as well. In a word, at that point in time, we knew how to convert stem cells to primordial germ cell-like cells. What we didn't know how to do is to take those cells and convert them to mature haploid post-meiotic gametes that would be of some utility. In a word, we understood the extragonadal component. We did not understand the intragonadal counterpart. The final frontier was really in vitro gametogenesis all the way. This was first accomplished by our friend Katsuhiko Hayashi, who by then was on his own and published a paper in Nature on the reconstitution in vitro of the entire cycle of the mouse female germline. This was in 2016, and the experimental paradigm involved starting with a stem cell, adding somatic cells, creating primary oocytes, eventually M2 oocytes, fertilize those, create a blastocyst, and voila, generate pups. In a word, we started with a stem cell and we ended up with pups. So in the rodent, specifically on the female side, we were able to recapitulate the process all the way. More of the same was accomplished on the male side, again in the rodent, this time by Mitinori Saito. So we knew how to go about taking a somatic cell in the rodent and converting it into a germ cell, and assuming we could fertilize that germ cell, we could proceed to have relevant embryos. This proved to be, of course, much more challenging and difficult in the human. The furthest we have come so far on the female side was reported by Professor Saito in 2018 on the pages of Science. He started with primordial germ cell-like cells, combined them with somatic cells, and guided those cells towards oogonia. In other words, he was able to create oogonia. What he was unable to generate was M2 oocytes, which are the fertilizable variety and really would be essential if the process were to be complete. And so we are left with a certain gap that needs to be addressed. But once that has been accomplished, the scientific and translational promise can be substantial. On the scientific end of things, we would finally have an inexhaustible supply of germ cells. We could do what the scientists like to do, is knock out one gene at a time and ask what happens, so-called null mutant analysis. And we could study, for once, germ somatic cell interactions in ways we could not do heretofore. On the clinical side, we could, for the first time, reverse germ cell failure. And so the therapeutic implications are profound. We could replace gametes in the event that they were missing. We could edit gametes if, for one reason or another, they are chromosomally abnormal. For example, say patients with Turner syndrome. And for the first time in human history, we are going to be proceeding to realize the prospect of same-sex genetic parenthood. This has now been reported on the pages of Nature. It's a separate conversation that I sometimes give. We will not go into details today. Suffice it to say that a notion that was unthinkable until relatively recently has become a reality thanks to in vitro gametogenesis. But the main impact of IVF, of IVG, one would have to say, is on IVF. It will eliminate the need in gonadotropin stimulation, and for that matter, egg retrieval. Most of the time women spend today in IVF involves injection with gonadotropins over 10 to 12 days, and then a minor, I say quote unquote minor, surgical procedure to retrieve the eggs. Those two could be skipped if and when we have IVG operational. We also will no longer require gamete donation, which occasionally we have to resort to in individuals who lack those. And from a practical point of view, this will convert IVF from an in vivo complex procedure mostly to a laboratory-based procedure. Now you will still need to prepare the endometrium with hormones, and you will still need to perform a minor surgical procedure, if you will, that is to say, transferring the embryos into the uterus in anticipation of pregnancy. Will that improve affordability and therefore access, since IVF is expensive? Time will tell. I think we have all observed the American genius of jacking prices up, even when that wasn't exactly called for. And so, will IVF actually become affordable? Is a big question. Today, it's still quite expensive. Some states cover the costs in part, but that's a limited number of states. And so what, if anything, will happen here? Only time will tell. None of this, of course, can or should proceed without some regulatory oversight. This is where FDA jurisdiction comes in. The entity within the FDA which reviews these types of application is known as the Center for Biologics Evaluation and Research. And in that subunit, there is a further subunit, if you will, that deals with human cells, tissues, and products. Now, you might ask yourself, why is all of this work coming from Japan? Why is there very little, if any, US publicly funded research, that is to say, NIH-funded research in the United States. Well, this has to do with something known as the Dickey-Wicker Amendment, which was enacted in 1996, and it prohibits U.S. publicly funded, that is to say NIH-funded, embryo research, which means that if you're an investigator who wants to study human embryo research, you cannot apply for a grant to the NIH because it will not be funded. The NIH is prohibited from funding such grant applications. And that's been true since 1996. The amendment is religiously attached to the US budget year in and year out, and therefore is still in effect today. Now, all of that aside, we are dealing with technology that could ultimately produce gametes to order. And I will briefly mention that IVG has now been embraced by the private sector in the US. One of the companies involved is called Gamito, and it uses a product called Fertilo, and it's about to enter US phase 3 clinical trials, which the FDA approved, or didn't approve, I'm sorry, received. But given all the difficulties we're experiencing at the FDA and elsewhere, the approval has yet to be granted. And so at this point, IVG, in the US at least, is mostly, if not exclusively, the domain of the private sector. So stay tuned. This is a rapidly moving front, and time will tell, of course, when and if it's fully realized, and when and if its full potential is brought to bear. But it's important to be cognizant of the fact that this train is coming down the line, and it's just a question of time before it will become an applicable reality that will serve men and women whose reproduction function in one way or the other is compromised. So with that, I'm going to close here, and I'll be pleased to entertain any questions. So thank you very much for the opportunity, and all the very best.
Thank you, Dr. Adachi. Does anyone have any questions? I think it's kind of stunning to think about the possibilities, and also the blockage that you just pointed out in terms of what happens in mice or sheep doesn't always translate so well into humans. And I'm thinking in particular about this idea in the bovine model, where you can take an embryo and separate it into separate cells and they all can grow. And you can't actually do that in humans. The embryo cannot be parsed. And have we ever discovered what the barrier is to that? Do you know? And would that be similar to what you think might be the blockade here with the induced pluripotential stem cells?
No, so I think you're right, absolutely right in pointing these shortcomings. And only time will tell whether or not these barriers can be overcome. I already made note of the fact that because of the pro-life, pro-choice debate in the US, Americans are unlikely to contribute their otherwise significant insights and talents to this issue. And so we will have to rely primarily, if not exclusively, on the contributions made in Japan. What their goals are, where they're heading, what the Japanese government has in mind, of course, I cannot speak to. But it is a peculiar situation that we find ourselves in because of our internal challenges. Now, it's true that the Japanese investigators excelled in every way and almost certainly are going to continue to do so. Some of their work has been adopted now in the UK, and so there is some effort underway there. But in many ways, as I said several times, I think today, this topic is really a future topic. It is something that the young members of the audience are likely to see realized, are likely to take advantage of, are likely to put to good use. And so how long it would take to get there, of course, I don't know. But nothing moves very fast. And so I think we can safely bet on a few decades before this is commonplace, before this is widely applicable by our successors in reproductive medicine. But I'm convinced that one way or the other, it will come to pass. It is too good an opportunity to forgo.
So a while ago, the California Institute for Reproductive Medicine kind of was funded by the state of California. And do you know if it's funding any research related to this? Because I do think the West Coast is often very differently positioned than is the East Coast for this kind of research. And you and I know this because we were there.
Yeah. Well, you know, it would take a progressive state, a progressive organization, one with the appropriate resources and mechanisms in place to essentially substitute for the federal government. And to date, I'm not aware of any such undertaking, which is why this is a future field rather than a present-day field. But it's difficult for people like us not to see the incredible potential here and the fact that what we do may be fine, but could be done a whole lot better and could reach many more people than we currently can. And so to me, this is a no-brainer, even though I tried to point out repeatedly that we're not there yet. And it will take some time and some doing, but I have to believe that sooner or later this is inevitable and that our successors will hopefully run with it.
So for the burgeoning physician scientist, do you advise a trip to Japan if they're interested in this? Because there's nowhere else in the US, right? Oregon's not doing this. California is not currently doing this. I think CIRM actually collapsed, the California Institute for Regenerative Medicine. I'm not positive that it did, but I don't think I've heard much from it recently. So for those who would be interested in this, they would have to go somewhere else, you think?
For the time being, hope springs eternal, and evolution is unstoppable. So we can hope, and I don't want to say pray, but hope that in time, shall we say, sanity will prevail, logic will prevail, and that we will exercise the appropriate separation between church and state. It's not clear that the church needs to be involved in this process. It is right now, but I have infinite hope in the common sense and eventual evolution of the United States and other nations to a point where mentioning this in the context of a presentation may be a non-starter to begin with, or at least that's how I would like to hope it will be.
So you're with the National Academy of Medicine now, right? This was the how this report got commissioned, right?
I'm
And
sorry?
the report that you just reviewed from the National Academy of Medicine was commissioned, right?
Yeah, so those 2.5 days that we met in Washington about IVG, that was summarized in a small booklet that was issued by the National Academy and is available to anybody, if I'm not mistaken, for free by downloading it from their website. And it summarized everything you could say about IVG 2.5 years ago.
Mm-hmm.
Not a huge amount has changed since then, because what we are all waiting for are new breakthroughs on the human side.
Mm-hmm.
And in the last 2.5 years, there may have been some background work that you and I may not be cognizant of, but nothing has been published since the science paper I showed 2 years ago. So this is clearly an evolving arena, and I hope I presented it exactly that way. But when things happen and are in evolution, it's important for all of us to be cognizant of them so that when they finally make it or make the big time, we are not taken by surprise or say, where have we been the last 20 years? I think this way, there is a certain progression that allows all of us to get used to an idea that is going to be part of what I called at the beginning stem cell medicine.
Mm-hmm.
I mean, the fact that you can make a paralyzed man walk, the fact that you can treat Parkinson's disease, gives us all hope that sooner or later we will be able to do some of the same and more in reproduction. This is not hypothetical. It's just a question of time.
I think that's really the message, isn't it? That the progression of knowledge is real, and that it does need to be harnessed and directed in a humanistic way. And I know that I have read many of your articles that are, thank you, because you send them. I don't have to work very hard, but they really do try to keep us aware of the humanistic abilities that we are harnessing to relieve human suffering. And I think sometimes people underestimate the amount of pain associated with infertility and don't understand what that feels like. From a personal perspective, it often feels like death, even though the person is still alive. But if their desire to have offspring is not met, then it's very painful psychologically for people. Even though nothing has been said about this recently that I have seen, I really feel like that barrier of resonating with other people's pain is still one of the bigger barriers, is that infertility continues to be discounted as a condition and sometimes not even recognized as a disease. And so to me, I think we have to go through another evolution psychologically as a society to recognize that. And we have some of our residents are interested in this topic of access that you broached just briefly. But I do think we've all struggled in our careers to have infertility be taken as a serious subject. And I wonder if you have any reflections about that.
Well, really not beyond what we already said. I think you said it all very well. You encapsulated, I think, the gist of what I was trying to convey. This is not something we can apply tomorrow. But the potential is so huge. And the societal effects are so profound that staying ignorant on the moving front that is likely to take hold within not maybe our lifetime, maybe not, depending on how young you are, I think is just important to embrace and realize. This will evolve, this will change, this will become more widely appreciated. I have been speaking about this for some time now, and I've been writing about it for almost 10 years, simply because of all the reasons I just mentioned, plus my original impression that has never been changed as to the talents of the Japanese investigator who are moving this front forward at this point single-handedly. It's just remarkable to see the kind of brain power they bring to the table. Kyoto University is perhaps the Harvard of Japan, some might say. I mentioned to you the fact that it's home to a Nobel Prize winner, and probably to more than one. So I don't think our trust is in any way misplaced. It's, in my view, just a question of time when all the scientific obstacles are overcome so that a technology that is now lab-based or limited can be released to be of service for the public.
Well, having witnessed some of the revolution in the early days, I think it makes you a believer in the future. At least that's the imprint it's left on me. And I want to thank you for illuminating us again about what I would say emerging topics of incredible interest to everyone, I would think. And for helping us understand in particular induced pluripotential stem cells and what they might do. And, I know that there were barriers in the past in terms of funding. I often hope they go away, but, they haven't so far. But I also hope that those listening, who are voters will somehow help out in that domain as well. So thank you again, Dr. Adachi, for joining us. It's been a distinct pleasure. And I know that we should hear more from you about some of these topics. So when I get one of the papers or so, I'm gonna make sure I distribute it to our audience here. Thank you.
Thank you.
Any questions, anybody else? All right, thank you guys. Bye.